Okay, we have on the board this integral from 3 pi over 2 to minus pi sine 12/5 x over sine 12/5 x plus cos 12/5 x, which I forgot to put in there. Okay, so to get started, there's a lot of intimidating things in this to make it kind of scary, but what we need to notice is this is actually something where we can use what's called the King's principle, and the King's principle allows stuff like this to be simplified very quickly and solve fast, even though it looks impossible. Okay, and so the first step for this is going to be use substitution, and what we want to do is we want to add our boundaries. So we're going to add, we'll just write this out, so we're going to add 3 pi over 2 plus minus pi, and then minus our x value. And then we can just kind of clean that up a little bit. 3 pi minus 2 minus pi is actually pi over 2 minus x. And then from that we can extract our x value, which is going to be pi over 2 minus u. And then we can get our dx value, which is just going to be minus du. Then we can make our substitution like we would in any case, but we want to fix our bounds first. So if we put 3 pi over 2 in here, we end up with minus pi. And then we'll put a minus pi in here and we end up with 3 pi over 2. So notice it actually just flipped around our boundaries from what we had originally. Then making our substitution in here for x, you notice we got more complicated looking angles now. But this is okay because what we can use is the complementary angle formula on all of these. Okay, so we have our complementary angle formula over here on the right. And all that's going to do is just going to allow us to flip our sines to cosines and cosines to sines. So we'll rewrite this, but before I do that, one thing to adjust, we have this minus sign. What we can do is use this, put this in front, and then we'll use this to flip the bounds. So we can rewrite this as 3 pi over 2 minus pi, which is back to what it was. And then we'll need to rewrite all this business. Okay, so rewriting this, you notice we got everything back to just an angle of u with the complementary angle formula. And one thing to notice is actually our denominator looks basically the same as it did up here, but we went from having a sine to a cosine. Now for the next step, what I want to do, because this is a definite integral, the variable name doesn't matter, so what I can do is change all my u's to x's and rewrite this again. Okay, and now we just have the same integral over here in terms of x. And then one last step before I clean up the board, I'm going to just call our initial integral I, and because all we've done is make substitutions, this is equal over here, so then this down here is also I. So what I want to do now is what I'm going to add this integral to this integral. They're the same, and so we're just going to have two copies, and let's see what happens. Okay, and so now you notice we have two copies of the integral, but we've added one version of it to the adjusted version over here. But because we have it all under x, we can do this all in one integral and combine it together. And also notice that we have the same denominator in each of these, so we can actually just add the numerators. But when we do that, when we add the sine 12/5 plus cos 12/5 x, we actually end up with the exact same thing on the denominator. So the beauty of this is all going to cancel out and be 1. So then we're just left to integrate 1, which is going to be super easy. That's just going to be x. We're going to evaluate that from 3 pi over 2 to minus pi. That's going to be just 3 pi over 2 minus a minus pi is a plus pi, so that's going to be 5 pi over 2. And that's very close to our real answer, but the one thing we need to do is we got to realize this is two copies. So we just don't want to forget that 2, but we can divide both sides by 2. And we're left with our final answer, which is going to be 5 pi over 4. I got this problem for my quiz, King's Rule Integrals. I'll provide a link in the description. Hope you check that out. A lot of good variety in problems like this. Thanks for watching. Please like and subscribe. Have a great day.